How does Adderall affect the mesolimbic pathway? Well, to answer that question, first, this is you, and this is your brain.
The mesolimbic pathway begins in the ventral tegmental area, or VTA, and sends dopamine to the nucleus accumbens and the prefrontal cortex.
This pathway controls motivation, reward, focus, and learning. When a neuron fires, dopamine is released into the synaptic cleft, the small space between neurons. Dopamine then binds to receptors on the postsynaptic neuron.
These dopamine molecules bind to dopamine receptors labeled D1 through D5. These receptors are most concentrated in the central nervous system, and each has different roles. Once dopamine binds to its receptor, it activates a G protein-coupled receptor. This triggers the enzyme adenyl cyclase, which increases levels of cAMP inside the cell. Higher cAMP levels activate protein kinase, starting a phosphorylation cascade. This cascade amplifies the signal inside the neuron. These activated enzymes reach the nucleus and increase gene transcription.
This strengthens neural connections involved in learning, motivation, and attention. So, now that we've looked at the normal pathway, what happens when we add Adderall into the equation? Well, Adderall contains two amphetamine molecules, dextroamphetamine and levoamphetamine. These drugs increase the availability of dopamine and norepinephrine in the brain.
Amphetamines increase dopamine by promoting its release and preventing its reuptake. This causes higher dopamine concentrations in the synaptic cleft, especially in the mesolimbic pathway. Increased dopamine helps the brain determine which goals are valuable. Dopamine filters out irrelevant stimuli, allowing stronger focus on a single task. Dopamine also modulates brain circuits in the prefrontal cortex, improving working memory, alertness, and motivation, which is why Adderall can reduce ADHD symptoms.
Studies show that amphetamine-sensitized rats have a greater number of spontaneously active dopamine neurons. This means dopamine neurons fire more often, strengthening reward signaling.
However, when dopamine levels become too high through artificial stimulation, the reward signal becomes overwhelming. These intense reward signals can drive compulsive drug-seeking behavior, increase craving, and addiction. The brain begins to prioritize the drug over natural rewards.
So to answer the original question, Adderall affects the mesolimbic pathway by enhancing dopamine signaling, which improves focus, motivation, and working memory. But excessive dopamine stimulation can overstimulate the reward system and increase the risk of dependence. Thanks for watching.